In this class, I'll explain by taking one circuit diagram about Kirchoff's two laws. Okay, now see, I take the circuit diagram, and that circuit diagram is like this. Draw this circuit diagram, and this is the external resistor. That value is given in the problem as 9 ohm, 9 ohm, and this is 8 volt and 1 ohm, 1 ohm, and this is 12 volt and 1.5 ohm, 1.5 ohm, and this is I1. Current is passing like this, and this is I2, and here this is I3. The question is find I1 and I2 in the circuit. I1 and I2 in the circuit. So with that we can calculate I3 also. In the last class, I said to you directly how to calculate I3 by using the formula E1 by R1 plus E2 by R2 by 1 plus capital R into 1 by R1 plus 1 by R2. I said to you one question, right? So instead of calculating I3 in the circuit, if I want to calculate I1 and I2, how come we calculate I1 and I2 separately by using the Kirchoff's laws? For that, here I consider this circuit diagram, and I'm naming this circuit diagram by labeling like A, B, C, D, A, B, C, this is D, E, and F. Like this labeling considered. At first, for solving this, I'm taking that this is the direction. Observe carefully. This is the direction. So once I consider this is the direction, how come we consider the loop? Apply the second law from. So if you want to apply the second law, need to take the loop closure circuit. So start from A, B, E, F, A, B, E, F, A loop. So loop means from where you started, again need to reach the same point. You started from A and reached A also. A again. It means what? The loop is completed. The circuit is completed like this. So this direction is anti-clockwise direction. Anti-clockwise direction. Okay. Are you following, ma? Are you following, ma? Now, here start from A to B. A to B. So A to B I considered here, but here there is no cell and there is no resistor. In the branch AB, there is no cell and no resistor. Just leave it. And then next I am taking the BE. BE. So BE means B to E I am moving. You are moving in this direction. You are moving in this direction, B to E. But the current is in the opposite direction. Observe carefully, ma. You are moving from B to E, but the current is in opposite direction in this branch. So the opposite to the direction of current, the potential difference is positive. But here there is no resistor straight away. But within the cell, internal resistance is present. Within the cell, internal resistance is present, and that is the reason here we are taking that there is existence of a cell. So if the symbolic representation of configuration of the cell is mentioned like this 12 volt comma 1.5 ohm, this can be represented as the cell is in series to the internal resistance like this 1.5 ohm. We can mention like this. In the bracket, if they mentioned, we need to assume the internal resistance like this to the cell in series. Okay, now here I consider that at first I am taking the cell here, positive terminal, and this is the negative terminal, positive to negative. high potential to low potential. High potential to low potential means what's the value ma? Low potential, no, finally minus. What is the value of that? 12 volt. So minus 12. Minus 12. And then you are moving after the cell through the resistor. So the resistance value is 1.5 ohm. Previously I said to you that this is I2. I2 is current passing. You are moving from B to E. Here the direction is opposite. Once the direction is opposite, you need to take the sign as plus. Now what is the current? I2. What is the resistance? 1.5 ohm according to Ohm's law. IR. 1.5 ohm. Okay. Now BE completed. Next, move from E to F. E to F. So in the case of E to F, there is no cell and there is no resistor. So just forget about that. Forget about that. Okay. And then move from F to A. F to A. So if you consider the F to A, again the configuration of the cell is 8 volt and 1 ohm. This symbolically like this, but I need to take for your understanding purpose, I considered one resistor. This resistor is in series to the cell, and that's why this is the internal resistance. Already given the value as 1 ohm. Given the value as 1 ohm. So that I mentioned like that for your understanding purpose actually. So now F to A, if you are moving, the current is I1. See the direction here? I1 is like this. I1 is like this. Okay, now, so the current is moving from F to A. At first cell came here. You are moving from F to A, and the direction of current also same in that branch. Are you getting ma? So if the direction of the current is same in that branch, here I am taking the concept it as negative sign, minus. Both the directions are same. Your moving direction and the direction of the current both are same. If the direction in the same as the direction of current, then the potential difference is negative. Potential difference is negative. So minus. Now what is the current here? I1. And what is the resistance here? 1 ohm. Okay. Then afterwards, move F to A again. After resistor, here you got the cell. What is here, ma? Cell you have. At first, which terminal is present here? Negative terminal. And this is the positive terminal. Negative to positive means what? Plus. Plus. So EMF is 8 volt. 8. Now you reached A. So you started from A. And reached again A. So loop completed. Loop completed. Are you getting the point, ma? Loop completed. Once the loop completed, then the entire value became 0, equal to 0. Now here minus 12, this is 1.5 I2, 1.5 I2 minus I1 minus 12 plus 8 minus 4 equal to 0. Then 1.5 I2 minus I1 is equal to minus 4, send that side, that became plus 4. Plus 4. This is equation 1. This is equation 1. In the same way, I am taking another loop. See here, I am taking another loop. That loop is like this. Again, anti-clockwise direction. Are you getting the point, ma? Anti-clockwise direction. So now from where to where need to move? B, C, write the name of the loop. B, C, D, E, B. Loop. BCDEB loop. So from this loop here I am taking at first which one I need to consider? BC. So BC means here in this branch there is no cell and no resistor. In this branch there is no cell and no resistor. So here we are taking the concept it as just leave that BC branch and then move to the CD. So in this case, CD, there is one resistor. You are moving in this direction. Current also in the same direction along the CD. And that's why here that is minus. I3 resistance current is I3, resistance is 9 ohm, 9 minus I3, 9. That is 9 I3 after that. Then after completion of CD, move to DE. Move to DE. So in the case of DE, there is no cell and no resistor. Just forget about that. Just forget about that. Are you getting ma? Okay. Now move to the EB. EB. Here the existence of cell and resistor. At first resistor came. You are moving in the direction of EB. The current also in the same direction. So minus again. Minus. What is the current? I2. What is the resistance of the resistor? 1.5. Then afterwards, move from negative to positive. Negative to positive means low to high, low potential to high potential. Negative to positive, that is positive. What is the potential? 12. That is EMF. And reach to the B. Once you started from B and reached again to the B, thereby the loop is completed. Once the loop is completed, need to place equal to 0. Equal to 0. Now, if you solve this, then this is nothing but minus 9I3 minus 1.5I2 is equal to minus 12. Is equal to minus 12. This is equation 2. Equation 2. Observe carefully, ma. In the equation 1, you have I1 and I2. In the equation 2, you have I2 and I3. In this case, if the equations are like this, it is impossible to solve. It's impossible to solve. So here we need to get first equation is in I1, I2. The second equation also in I1, I2. Then there is a possibility of solving the equations. So in the place of I3, I need to consider I1, I2s. The second equation should be taken in the form of I1 and I2. Thereby, we can solve that equation. For that purpose, just again go to the diagram. Go to the diagram. So in the diagram, observe carefully. I1 is coming from here. I1 is coming from here like this. I2 is coming from here like this. And both I1 and I2 are meeting at this point B. At this point B. And both will be given as I3. So here I am taking that I3 is equal to I1 plus I2. I3 is equal to, what's the equation? I1 is coming from here. Observe the AB branch. I1 is coming. I2 is coming from here. Observe EB branch. So I1 and I2 both are meeting at B junction, at junction B, and apply the Kirchoff's first law, and thereby I1 plus I2 is equal to, what's the value? I3. So the second equation I am replacing like minus 9 into I3 replaced with I1 plus I2. I1 plus I2 minus 1.5 I2 is equal to minus 12. Now, minus 9 I1, minus 9 I2, minus 1.5 I2, minus 12. Now, here minus 9 I1, minus 9 and minus 1.5 minus 10.5 I2 is equal to minus 12. This is the third equation. Now, the first equation is consisting of I1 and I2. The third equation also consisting of I1 and I2. If you solve 1 and 3, you will get the values of I1 and I2. I1 is equal to minus 1 ampere. I1 is equal to minus 1 ampere. And then I2 is equal to 2 amperes. You will get it as. This is the solution of this. Okay, like this, you can solve this problem by applying the Kirchoff's second law, by using the loop law or second law, like this. Two equations we got here, first equation and second equation. In the first equation, we have I1 and I2. In the second equation, we have I2 and I3. Okay, so I2 and I3 also converted into I1 and I2 by taking the Kirchoff's first law again, or junction law, and thereby here I3 is equal to I1 plus I2. Take the second equation, substitute in the place of I3 as I1 plus I2, and we can solve, we can get the equation as third equation in the form of I1 and I2. And finally, if you solve I1 first equation as well as the third equation, then you will get the values of I1 and I2 as I1 is equal to minus 1 ampere and I2 is equal to 2 ampere. 2 ampere. Okay, like this we can solve this problem. Listen, ma. This is one question given in the competitive exam, where the current is moving from A, that is at high potential. When the current is moving from A is at a high potential, at B, there existence of low potential. Low potential means minus. Minus. Okay, see here, ma. Once you are moving from here, at A, the potential is apply the Kirchoff's second law. At A, the potential is plus, nothing but positive potential, because the current is moving from this point. From where the current is moving, from where the current is starting, that is at a high potential. That point is at high potential. Remember very clearly. From where the current is started, from where the current is moving, wherever you consider the initial point, that is at a high potential, that is plus. Here A is at high potential, and that's why the potential at A is mentioned as VA, plus VA, positive sign you need to take, plus VA. Then move like this. All are in series combination, no? When all are in series combination, then same current passes. The current given in the problem as 2 ampere. The same 2 ampere passes through the 2 ohm resistor. The same current passing through the 1 ohm resistor also. Are you getting ma? Now 2 ampere, same direction is the same. Here you are moving from A to B. The current also along A to B. So the potential difference is negative. Potential difference is negative. Okay, now here I am taking that minus. What is the current here? 2 ampere. What is the resistance here? 2 ohm. Okay, next move to the cell. At first you will get here positive, after that negative. High potential to low potential, positive terminal to negative terminal. So you will get it as minus. What is the potential here? 3. And again the same current is passing like this. What is the current here? 2 ampere. And need to take sign minus. Why? Because same direction of current, you are moving in the same direction, A to B. So minus. What is the current here? 2. What is the resistance? 1. And reach to B. B is at negative potential, minus VB. Thereby here the circuit, the branch is completed. So equal to 0. Equal to 0. Here we need to calculate potential difference between A and B. So VA minus 4 minus 3 minus 2 minus VB equal to 0. Then VA minus VB, potential at A is VA, potential at B is VB, potential difference is nothing but VA minus VB. Minus 4 minus 3 minus 7 minus 2 minus 9 equal to 0. Then VA minus VB is equal to, send the minus 9 to that side, then you will get the plus 9, that is nothing but 9 volt. This is the potential difference between the A and B given in one competitive exam. Okay. Listen, the terminal voltage of the battery, here what we need to calculate? Terminal voltage. Terminal voltage. What is the meaning of terminal voltage? Terminal voltage is nothing but across the cell, whatever the voltage is present in the open circuit, that is called terminal voltage. So listen carefully. Across the cell, whatever the voltage is present, that is called terminal voltage. Remember one important line. The terminal voltage of the cell, when the cell is in open circuit, is equal to EMF of the cell. The terminal voltage, for example, this is the cell. This cell is not connected in the circuit. Then what is the voltage across the cell? The terminal voltage across the cell, which is equal to EMF of the cell. EMF of the cell. When the cell is in open circuit. When the cell is in open circuit, the terminal voltage of the cell is equal to EMF of the cell. Just remember this. Now, here the cell is connected in the circuit. The cell is connected in the circuit. That's not open circuit. That is a closed circuit. That's not open in this open circuit. That is a closed circuit. Okay. So now, how come we consider the terminal voltage of the battery whose EMF is 10 volt? EMF is equal to E is equal to 10 volt given in the problem. And then internal resistance 1 ohm. Internal resistance small r is equal to 1 ohm. Internal resistance represented with the small r, that is equal to 1 ohm. When connected through an external resistance of 4 ohm, external resistance represented with capital R, and that is nothing but 4 ohm as shown in the figure. So here one diagram is mentioned in the problem, and that is like this. See here, man. So this is 4 ohm. In the problem they mentioned 10 volt. Remember carefully, when the any resistor is in series to the cell, that you treat it as internal resistor. Internal resistor. Any cell is in series, any resistor is in series to the cell, then you treat it as that as internal resistor, 1 ohm. Here, like we need to calculate the terminal voltage. So for that purpose here at first we can calculate what is the current passing through the circuit. Listen, this is the positive terminal, this is the negative terminal. The current is passing from positive to negative externally. In the external circuit, the current passes positive to negative. I need to calculate the current. Take the Ohm's law. V is equal to nothing but potential, nothing but EMF. 10 is equal to so here you have one formula. EMF E is equal to like external resistance. This you treat it as R, I into capital R, same current passes like this, plus I into within the cell, what is the internal resistance? 1 ohm, that is I into small r. Capital E is equal to I capital R plus I small r. Then E is equal to I into capital R plus small r. Then with that, I is equal to E by capital R plus small r. Capital R plus small r. Okay, now what is the E value? EMF is 10 volt. Capital R is nothing but external resistor, given that 4 ohm. Small r is nothing but internal resistance, given in the problem as 1 ohm. 10 by 5 is equal to 2 ampere. This is the current passing through the circuit. This is the current delivered from the battery. Now we need to calculate the terminal voltage. So once you need to take the terminal voltage, observe carefully, the same formula once again I am taking. E is equal to I capital R plus I small r. I capital R and I small r. Now E is equal to this I capital R, here I am writing that V plus I into small r. Remember, once you are placing in any formula as V, that can be applicable only for external resistor. According to Ohm's law, V is equal to IR. That's it. That part is over. No confusion. But in any formula, you are substituting as capital V like this. Then that can be applicable only for external resistor, I into capital R, not for I into small r. This is also according to the Ohm's law, but specifically you are representing as V here. This V you are representing means that is the potential difference across the external resistor, like this. So V is equal to E minus plus IR, take this side, minus IR. This is the formula for terminal voltage. Okay, across here as well as across here, you can represent V. Now what's the formula? E means 10. I means what's the value? Current 2 ampere. Internal resistance is nothing but what? 1 ohm. 10 minus 2, that is equal to what's the value, ma? 8 volts. That's the answer. One circuit I am taking here. Just observe. Like this, one circuit is present, and this is A. Draw this diagram. This is B, and this is C. And resistance is also mentioned as R1, R2, and R3. R1, R2, and R3. This is the O junction. The question is, a circuit has a section A, B, C as shown in the figure. A, B, C. This is one in one circuit. This is one small part. Section is nothing but small part. Okay. Now, if the potentials at points A, B, and C are at A, the potential is V1. They mention like this. At B, the potential is V2. At C, the potential is V3. V1, V2, V3. Calculate the potential at point O. Calculate the potential at point O. At this point, what is the potential that we need to calculate? Are you getting the question mark here? Are you getting the question? Here, this is the one section in the circuit. One section in the circuit. Section means small part of the circuit. Section means small part of the circuit. So, like this one resistor R1, and this is R2, and this is R3. The potential at A is given that V1. The potential at B is given that V2. The potential at C is given that V3. We need to calculate what is the potential at the junction. What is the potential at O in the problem? ఈ ప్రాబ్లంలో O అనేటువంటి పాయింట్ దగ్గర పొటెన్షియల్ ఎంత ఉంటుంది that we need to calculate. So straight away I am taking the formula for that. That is V naught is equal to, if you know V1, V2, V3, R1, R2, R3 like this, then straight away take this formula V1 by R1 plus V2 by R2 plus V3 by R3 by 1 by R1 plus 1 by R2 plus 1 by R3. If you use this formula, then you will get the value of potential at O, VO. Just note that one. Then another question. Complete, ma? This is one circuit. Solve the circuit. Calculate the potential difference between A and B. VA minus VB. The answer is VA minus VB is equal to 20 volt. Solve this. Okay, ma? Now, another model. And these three are connected to these are the different models which you don't have. This is the R, and this terminal is A. This terminal is A, and this is R1, R2, R3, E1, E2, E3, E1, E2, E3, and this is the terminal B. Terminal B. What we need? Calculator. In the circuit shown in the figure, E1 is equal to 3 volt. In the problem given that E1 is equal to 3 volt and E2 is equal to 2 volt. E2 is equal to 2 volt and E3 is equal to 1 volt. E3 is equal to 1 volt. And capital R, R1, R2, R3, all are equal to 1 ohm. All are equal to 1 ohm. You will get the problem. 1 ohm. The question is, if the R2 is short circuited and the point A is connected to B, and the point A is connected to B, R2 is short circuited. This is not functioning in the circuit. R2 is short circuited. Okay. If the point A is connected to point B, these two are connected. These two are connected. Thereby, here this is not functioning properly, right? So, not connected. Find the currents through E1, E2, E3 and the resistor R. Find the currents. I don't know. Find the currents. Find the currents passing through E1, E2, E3 and capital R. So question in Tikra, the question is here, A and B are short circuited like this, connected with wire. So if the A and B or both the ends are connected with the wire, then this can be short circuited. Short circuited. So at that moment, here, what is the current passing through the E1, E2, E3 and capital R? That we need to calculate. Okay. So you try to solve this. Otherwise, I will tell you the problem in the next class. Okay. In the next class. Here, I1 is equal to 1 ampere. You will get I2 is equal to 2 ampere. I2 is equal to 2 ampere. And I3 is equal to minus 1 ampere. I3 is equal to minus 1 ampere. And what about I1, I2, I3? The cell through first cell, the current is I1. Through the second cell, the current is I2. Through the third cell, the current is I3. I1 is coming from here. I2 is coming from here. I3 is coming from here. All are meeting at this point and passing through the external resistor like this, and that is I. I is equal to I1 plus the current passing through the external resistor. I is equal to I1 plus I2 plus I3. Okay, take the Kirchoff's second law for this one. Take the Kirchoff's second law. I'll give the hint to you. Take the Kirchoff's second law. So from the Kirchoff's second law, at first you take the loop. Take the loop like this. How come you consider the loop? So this is, first you consider this. I'm naming the concept here. This is B, C, D, E, F, and this is G. I'm naming the circuit like this. Okay, at first take this loop. D, first loop is D, C, B, A, again B here. Here already B is there, no? G, and this I'm taking it as H, right? So now D, first loop. I'm giving the hint. Solve this. First loop is loop D, C, H, A, and B. Move like this. B, E, and finally D. This is the first loop. And second loop is start from H like this. H, A, this is B, B, and E, H. That is the second loop. And then third loop. By taking the third loop, you will get another solution. And take the H only. HA, and like this B, and move like this F, G, H. This is the third loop. By using these three loops, you will get three equations. If you solve those three equations, then you will get I1, I2, I3 values. And after taking the I1 and I2, I3 values, substitute like this I is equal to I1 plus I2 plus I3, then you will get the current passing through the resistor. Okay, so I1 is equal to 1 ampere. You will get the answers as I1 equal to 1 ampere, I2 is equal to 2 ampere, and I3 is equal to minus 1 ampere. Solve this question.